in this unit, we've learned about 5 quantities that we can calculate or measure. Those quantities being distance, displacement, average velocity, instantaneous velocity, and average acceleration. Remember, average velocity is the velocity between 2 points in time, whereas instantaneous velocity is the velocity at a single point in time. Really, when we're creating a velocity versus time graph, we're plotting the instantaneous velocity at each time during the object's motion. There are 2 methods that we're going to cover about how to find those quantities, specifically those 3 quantities: displacement, instantaneous velocity, and acceleration. The first method that you could use is to draw a velocity versus time graph of the motion while keeping in mind that displacement is the area between the graph and the horizontal axis, and acceleration is the slope of the graph. There's another method for using finding those quantities, however. It's not just graphing. The method involves coming up with equations to calculate those quantities. There's 4 equations that we can use, and as always, you'll be given these equations on any assessment. The first equation is one you already know, that the average acceleration is the velocity divided by the time. The change in velocity, rather, divided by the time. Remember that the change in anything is calculated by doing final minus initial. So when we say the change in velocity here, we're looking for the final velocity minus the initial velocity, divided by the change in time, or the final time minus the initial time. The other 3 equations are new equations that we have not yet used. The first one being that the displacement, or delta x, is equal to 1/2 of the addition of the initial velocity and final velocity times time. The initial velocity, remember, would be an instantaneous velocity at whatever your initial point of motion is. And your final velocity is the instantaneous velocity at whatever the final point in motion is. Another equation is that the displacement is the initial velocity times the time, plus 1/2 the acceleration times the time squared. Our final equation says that the final velocity squared is equal to the initial velocity squared, plus 2 times the acceleration times the displacement. One thing I'll point out, it'll be very important for you to keep straight which symbol means which quantity. Also remember, displacement is often measured in meters, velocity in meters per second, acceleration in meters per second squared, and time in seconds. Anytime you see a VI or VF, that represents the initial velocity or the final velocity, and those are instantaneous velocities, because they're the velocities at a specific point in time. 2 other important notes. Remember that displacement can be calculated with the final position minus the initial position, and you also have to make sure that your units match. In other words, if something is in kilometers per hour, that would be a speed, then your distance, or displacement rather, better be in kilometers and your time better be in hours. If your units don't match, then you need to convert your units prior to plugging them into any equation.